Okay, let's talk about absolute value equations. Well, before we do that, let's talk about what absolute value is. All right, so absolute value is the distance from 0 to a given number. All right, so the key part of the definition is distance. And distance, as you know, is always positive. So, if you recall, absolute value bars look like this. So if I asked what the absolute value of 4 is, you're thinking, what is the distance from 0 to negative 4? Well, the distance is 4. So therefore, the absolute value of negative 4 is 4. So then, what's the absolute value of 4? Well, again, what is the distance from 0 to 4? It's also 4. So, whenever you take the absolute value of a number, just keep in mind the expression comes out of the bars as positive, unless there's something on the outside that forces them to be changed back. Say, for example, if I said, what's the opposite of the absolute value of negative 2? Well, the absolute value of negative 2 is 2, and then this right here makes it a negative 2. So, I'd make a note of that. I really like that. Okay? Hint, hint, hint. Okay. So, now we're going to apply this to equations. So, if A is a positive real number and if U is any algebraic expression, then the absolute value of U equals A is equivalent to U equals A or U equals the negative of A. Now, when you solve these equations, you should spot check your solutions. So let's run through, I think I want to do just 6 examples for you. All right, so let's start with the first one. Absolute value of x plus 4 is equal to 13. All right, so the first thing you want to make sure is that the absolute value bar's expression is completely isolated. Okay, it is, because there's nothing on the outside of the absolute value bars that's being added, subtracted, multiplied, or divided by the algebraic expression in the absolute value bars. All right, so we can break it up into the cases. So x plus 4 is equal to 13, or x plus 4 is equal to negative 13. And then subtract 4 from both sides, so x equals 9. Subtract 4 from both sides, or x is equal to negative 17. All right, so you really should spot check your answer. I'm not going to do it for all the examples, but I would just to make sure. So we're claiming that 9 and negative 17 are the answers. So if I plug a 9 in for x, so 9 and 4 is 13. Absolute value of 13 is 13, and that checks. And then check negative 17, so absolute value of negative 17 plus 4, does that equal 13? Well, negative 17 plus 4 is negative 13. Absolute value of negative 13 is 13, it checks. So, 9 and negative 17 are the answers to that particular example. All right, let's look at another one. So here I have the absolute value of 3x subtract 1 plus 10 is equal to 12. Now, as I said in the previous example, you want to make sure that the absolute value bars are isolated. Notice here I have a 10. You must isolate the absolute value bars. Subtract 10 from both sides. Absolute value of 3x minus 1 is equal to 2. Then break it into cases. So 3x minus 1 is equal to 2, or 3x minus 1 is equal to negative 2. Solve both parts. So 3x is equal to 3, x is 1. Add 1 to both sides, so 3x is equal to negative 1. X is negative 1/3. And I will leave the check up to you, but it does work. And if you do spot check, you must go back to the original equation, the one I'm boxing in purple. All right, let's look at another example. All right, so here I have 6 multiplied by the absolute value of 5x minus 2 minus 1 is equal to 17. All right, so we have to isolate the absolute value bars. So we're going to first add 1 to both sides. So that gives me 6 times the absolute value of 5x minus 2 is equal to 18. Now, typically we would distribute that 6 across the quantity 5x minus 2, but these are absolute value bars, and distributing will not always work. So the best thing we should do is just divide both sides by 6. So if it were parentheses, yes, you could distribute, although you don't have to. But since it's absolute value bars, you can't. So don't do it. So absolute value of 5x minus 2 is equal to 3. Break it up in the cases. 5x minus 2 is equal to 3, or 5x minus 2 is equal to negative 3. So add 2 to both sides, so 5x is equal to 5. So x is equal to 1. Add 2 to both sides, so 5x is equal to negative 1. Divide by 5, x is equal to negative 1/5. And again, I'm going to leave the check up to you. All right? So 3 more examples to go. All right, so here in example 4, I have the absolute value of x minus 10 is equal to negative 2. Well, now, first of all, you should think in terms of, well, I got a negative number here. Can anything in this expression that I can put in for x and then subtract 10 and take absolute value, will it ever be negative? No, it will not. So no solution. It's not going to work. But what if you actually did the problem? All right, so let's just pretend like we didn't pay attention to the negative and just did it. Okay? So I get 8 and 12. Well, if I check it, absolute value of x minus 10 equals negative 2. We got 8 and 12 as potential solutions. So if I plug in an 8, I get the absolute value of negative 2. Absolute value of negative 2 is 2, so 2 does not equal negative 2. So the 8 gets kicked out. And then if I plug in the 12, 12 minus 10 is 2. Absolute value of 2 is 2. And again, 2 is not equal to negative 2. So that's why it's no solution. All right? Moving right along. Example 5. Absolute value of 7x plus 4 divided by 8 is equal to 3. All right, so here, that 8 is not part of the absolute value bars. We still need to isolate, so I'm going to multiply both sides by 8 to make that fraction disappear. So I have the absolute value of 7x plus 4 is equal to 24. And then I'm able to break up into cases. So 7x plus 4 equals 24, or 7x plus 4 is equal to negative 24. And I guess I ought to mention, since it just now dawned on me, that if you think I'm going too fast, you can always stop the video. Okay, sorry about that. Subtract 4 from both sides, so 7x is equal to 20. So x is 20 over 7. Subtract 4 from both sides, 7x is equal to negative 28. X is negative 4. So we got 20 over 7, and x equals negative 4. Again, I'll leave it up to you to check the solutions. And the last example, I have 3 plus the absolute value of 8x subtract 6 is equal to 3. So again, I need to isolate the absolute value bars. Now, this 3 is not multiplied by the absolute value of 8x minus 6. You got to subtract it out. So I have the absolute value of 8x subtract 6 is equal to 0. Now, you might stop and think, well, can it ever be 0? Actually, it can, because remember, 0 is neither negative nor positive. So, 8x subtract 6, set it equal to 0. Now, obviously, you cannot set it equal to negative 0. Don't work that way. Add 6 to both sides. 8x is equal to 6 divided by 8. Therefore, x is equal to 3/4. And that takes care of our section on absolute value equations.